Hello YouTube, today we're going to be doing a circuits problem. Instead of using Kirchhoff's loop rules for this problem, which you've seen before if you've watched my previous videos, we're going to do a much easier way of solving this circuit, something more elementary. But the previous video I wanted to show was using MATLAB and just kind of going over the rules in general, and I just had this problem on hand. So you got this circuit here, and we're supposed to find V1, V2, V3, and I1 and I2 and I3, and we're given that the battery has 32 volts. And R is just simply 1 kilo ohm. So the first thing I always like to do is reduce the circuit into a single resistant. Like it's the battery and the resistor. That's it, because there's nothing fancy going on here in terms of like capacitors and inductors and etc. So let's start from the right and work our way to the left and notice the relationships that we have here. So this circuit can be redrawn as follows right here, right? So looking at the far right, you see 2R is in parallel with 2R with the resistor that has the I3 going to it. So 2 in parallel with 2 is simply 1, so that's 1R. So that's how we redraw the circuit here. So now we knocked off that little section of the circuit. Now let's look at this some more. What else do you see? Well, still looking at the far right end of the circuit, we notice that R and 1R are in series. So you can add them since they're in series, since resistors in series sum. And we can make that into one resistor, which 1 plus 1 is 2. So now we reduced our circuit even more. Let's keep going. Just like before, we have 2 R in parallel with 2R at the back there. So that can be reduced down to a single resistor in parallel, which 2 in parallel with 2 is simply 1R. And then look, it's a same thing as before. We got 1R plus R, and that will give us resistors in series, so that makes it a single resistor. We'll have 2R, and then look again, we got 2 in parallel with 2. We do it again, and we get 1R, and then we sum again. 1 plus 1 is 2. By the way, the battery volts was given as 36. Thought I'd write that real quick. So now that's our R equivalent. So we found the total resistance in this circuit. So now let's find the total current. So the total current, I, is the battery over the equivalent resistance. So we have 36 volts over 2 kilo ohms because R was given to be 1 kilo ohm. So now we have our total current is 16 milliamps. Awesome. Cool. Well, that's not what we're looking for, but it'll help us in the process for finding V1, V2, V3, I1, I2, and I3. So let's look at the highlighted sections here, V1 and I1. So let's look at V1. So V1 will be VB, so the voltage source coming from the battery, minus the current, the total current, times R, because that's what the total current is leaving. Something happened real quick, so sorry if it cut. So the total current is leaving out of the battery, so that upper left red arrow on the circuit there is IT times R, and that is the voltage, since V is equal to IR, going through that resistor. So we have to subtract the voltage from the battery and the total current coming into V1, and that was 32 volts minus 16 milliamps. Which is the total current times the 1 kilo ohm resistor, and that we find out to be 16 volts for V1. Now let's find the current. So the current would simply be V1 over 2R. So we have the voltage source there is what we actually now, or the voltage at that node there we know. So it's V1 over 2R, just going through that resistor. Pretty straightforward there. V is equal, or I is equal to V over R. So now we calculate as 16 over 2 kilo ohms. We have I1 is equal to 8 milliamps. Sweet. So now let's look at V2 and I2. So same thing. Let's look at the voltage first. So the voltage is V1 minus the voltage going through, or excuse me, that part's the current. The current going through the resistor. That would be V1 over 2R there, and then multiplied by the resistor R. So that would just simply give you V1 over 2 kilo ohms, and that is 16 over 2 kilo ohms, since we know that V1 is 16, and then V2 is simply 8 volts. Next, solving for current, we just look at that little section right there, and we got V2 over 2R, and that's simply, we know the voltage that we just calculated is 8 volts over the 2 kilo ohm resistor, and that would give you 4 milliamps. Cool. And the last section of the circuit here for V3 and I3. So V3 would simply be V2 minus V2 over 2R, and then times R. So the V2 over 2R is the current, and R is the resistor it's going through. And then we know it would be simplified to V2 over 2. We know V2 is equal to 8, so then V3 would be 4 volts. Then solving for current, we got I3. We got V3 over 2R, so we know the voltage at V3, and we know the current going through this resistor is, or the resistance through this resistor is 2 kiloohms. So we got 4V over 2 kiloohms, and then I3 is 2 milliamps. Cool. So just to summarize, we're looking for V1, V2, V3, I1, I2, I3. We were given VB and R, and then we got our current, we got our voltage, we got our current, we got our voltage, current, voltage, boom. We got everything we need. Cool. So we did it. So this is a simpler way, way less complicated. You can do it obviously on pen and paper rather than using computer programming to input your data into a matrix. But I just wanted to show this problem in another form. So I hope it helped, and good luck studying.